Good morning, dear student. In today's lecture, we are very much interested in the second important process, which is catalyzed by the organometallic catalyst, that is the monsanto acetic acid synthesis. So, we are very much familiar with this process, that is monsanto acetic acid synthesis, a process developed by the Monsanto in USA to produce acetic acid by carbonylation of methanol in presence of catalysts such as rhodium and I minus, and this process is called as Monsanto process. That is, uh, if you consider a general reaction, that is the methanol insertion of carbonyl into this methanol with the help of catalyst, sorry, that is rhodium I2 CO by 2 having net negative charge, that is 16 electron species at a temperature 180 degrees Celsius and 30 to 40 atmospheric pressure, 30 to 40 atmospheric pressure, and there is a conversion of this methanol, that is insertion of carbonyl into this methanol, and we get the acetic acid. So a process which is developed by the Monsanto in USA to produce acetic acid by carbonylation of methanol. This Monsanto acetic acid synthesis is also known as carbonylation of methanol in presence of catalysts such as rhodium and I minus. So, if you consider the steps in this Monsanto acetic synthesis, the first step is uh, if you consider the first step, that is the rhodium trihalide. So how this catalyst is formed, that is trihalide rhodium trihalide, that is RHX3 is converted RHX3 is converted to a complex that is RH I2 CO by twice having negative charge in presence of carbonyl and I minus, that is iodide. So the reaction is RHX3, where X is your iodine. So RHX3, it will interact with your carbonyl and I minus to forms this active catalyst, that is rhodium catalyst. So RHI2CO by twice having negative charge. If you consider this rhodium I2CO by 2 minus, it is an 16 electron species. So this catalyst is formed by the reaction of rhodium trichloride in presence of carbonyl I minus to get the active catalyst, that is RHI2CO by 2. So if you consider this catalyst, that is this catalyst, it is an 16 electron species, that is the rhodium, that is it is a member of cobalt rhodium iridium family. So it is a series of it is cobalt rhodium iridium series, so it is 3D, 4D and 5D. So this rhodium is belongs to this carbonyl group, and therefore its valence configuration is same as that of cobalt, and it is not carbon, it is cobalt. Okay, so the cobalt having 4s to 3d7 configuration, therefore the same configuration for rhodium and iridium, because it is belonging to the same group. So the rhodium contributes 9 electrons, and then iodine contribute 2, and then the carbonyl contributes 4 electrons, and one negative charge is there. So total 9 plus 2, that is 11, 11 plus 4 15, and 1 16. This is an 16 electron species. The net negative charge is minus 1 is there, so total 16 electron species is there. So let us discuss the important steps in this catalytic cycles, that is conversion of this methanol into acetic acid. So the second step is that this methanol react with hydrogen iodide to produce iodomethane, to produce iodomethane, that is CH3OH. It will react with HI, and there is a formation of methyl iodide, iodomethane, with elimination of water. So this is the second step. The third step, that is first step, is the formation of the active catalyst. Second, the conversion of methanol into methyl iodide. Then the oxidative addition of this iodomethane to the active catalyst, that is coordinatively 16 electron species. So the oxidative addition oxidative addition of iodomethane oxidative addition of this iodomethane to the four coordinated 16 electron complex, 16 electron complex, that is your RHI2 COY2 having minus. So this is the step, that is this rhodium, then the carbonyl is there, iodine is there, and having a negative charge is there. So it is four coordinated. So the reaction with methyl iodide, we get here oxidative addition. So the coordination number is increases by 2 units, and the oxidation state is also increases by the 2 units. So rhodium, it is CO, here also CO, then this is your iodine, this is your iodine, and this is your CH3. And for the so the conversion of 16 electron species into 18 electron species. So if you count the electron, the rhodium having 9, then the methyl group contribute 1 electron, so total 10, 11, 12, 13. These three iodine contribute 3 electrons. So it is 9 plus 1, 10, 11, 12, 13, 13, and this carbon will contribute 4, that is total 13 plus 4, 17, and 1 net negative charge to make 18 electron, that is 18 electron space. So this is the first step, that is the oxidative addition of methyl iodide to this rhodium complex and the conversion of 16 electron species into 18 electron species. No doubt the first two step is also important. The first step is formation of catalyst, second step is conversion of methanol into methyl iodide, and in the third step, that is oxidative addition of this methyl iodide to this rhodium complex and convert the 16 electron species into 18 electron species. The fourth step in this catalytic cycle, so if you consider the next step, that is the fourth steps, these steps involve this step involve these steps involve migration and insertion, migration and insertion of carbonyl molecule to form 16 electron acyl complex. So we know that whenever there is a sigma donor ligand is present and the carbonyl is present, then there is a chances of 1-1 insertion, that is alkyl migration or CO migration, involves migration and insertion of CO, either it is methyl migration or CO insertion is there. So this is our complex, that is rhodium CO rhodium, carbonyl, carbonyl is there, and this is iodine, 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 and this is your uh, CH3 group is there, having negative charge. So whenever we know that 18 electron species undergo insertion reaction, whenever there is a sigma donor ligands and carbonyl ligands are present, then it undergo migratory insertion reaction. So what you get here after migratory insertion, we get here RH, here we get C double bond O CH3, this is your carbonyl, this is your iodine, this is your iodine, this is your iodine, and to make if you count the electron, so this rhodium 9, 11, 9, 10, 11, 12, 13, 14, 15, and for to make 16 electron, it having a negative charge, that is your acyl complex is there, so this is your four steps, that is the first step is formation of catalyst, second is conversion of methanol into methyl iodide, third step is oxidative addition of this methyl iodide, a conversion of 16 electron species to 18 electron species, and the next step is the migratory insertion reaction, that is 18 electron species undergo migratory insertion reaction, but the condition is that uh, there is a sigma donor ligand such as hydrogen methyl group is present and pi acceptor ligand such as carbonyl is present, then there is a chance of migratory insertion to get acyl complex, which is your 16 electron species, 16 electron species. Okay, and this 16 electron species, there is addition of CO molecule. The next step, that is fifth step, is the addition of carbonyl. The fifth step is what? Addition of carbonyl molecules. Addition of carbonyl molecules is done to form 18 electron complex. 18 electron complex. That is, this is the complex, that is CH3 C double bond O, rhodium, this carbonyl is there, and this iodine is there. This is your negative charge, that is RHI3CO C double bond CH3. It is your 16 electron species. Then you have to add one carbonyl, then it is converted into this. So if you consider this is RH, it's carbonyl, this is your C double bond O CH3, carbonyl is there, iodine and iodine is there. And if you count the electron, then it is 9, 10, 11, 12, 12, 13, 13 plus 4, 17, and it having one negative charge to make 18 electron space. So this is the step. So first step is formation of catalyst, second that is conversion of methanol to methyl iodide, next oxidative addition of this iodomethane to this active catalyst to form 18 electron species. Then there is a migration, 1 migration, and then addition of this carbonyl, again convert this acyl complex, that is 16 electron complex, to 18 electron complex, and this complex undergo reductive elimination reaction. This complex undergo reductive elimination reaction. So let us discuss the last step of this reaction, that is reductive elimination. The sixth one is there. Reductive elimination. Reductive elimination of acyl iodide. to form. So this is your complex, that is rhodium. It is C double bond O, CH3 is there. So you can rhodium, C double bond O, CH3 is there. Okay. Then this is your iodine, iodine, iodine. Then there is a one carbonyl is there, carbonyl and carbonyl is there, and it having a negative charge. So total 9, 10, 11, 12, 13, 13 plus 4, 17, and it becomes 18. So it undergo reductive elimination. So reductive elimination. So acyl iodide. So this undergo reductive elimination to gives CS3 C double bond I plus what you get here RH CO CO iodine iodine and having negative charge. So this is again your 9 plus 9, 10, 11, 11 plus 4, 15, and 16 electron species. This is your active catalyst, and we get this, that is acyl iodide. And finally this acyl iodide, the next step is what? This final acyl iodide undergo hydrolysis reaction. So this acyl iodide, it undergo hydrolysis reaction to gives acetic acid plus hydrogen iodide, and this is the product. So this is all about the monsanto acetic acid synthesis. So it is very simple. So you just remember the conversion, that is carbonylation of this methanol in presence of rhodium catalyst and formation of acetic acid. The different step is there. The first is formation of the rhodium complex by the reaction of this rhodium trihalides with carbonyl and I minus. Then there is a conversion of methanol into methyl iodide. Then there is oxidative addition. Then there is a 1,1 insertion. Then addition of carbonyl, and finally the reductive elimination. After that, whatever the complex which is whatever the species which is formed, which undergo hydrolysis to give acetic acid plus H. So this is all about one side acetic acid synthesis. In next lecture, we discuss the remaining parts of that chapter. Thank you.